3 years ago, I was in the process during the spring of 2016 of putting up some solar photography, solar film, time-lapse footage that was intended that it would show if there is sun expansion or shrinkage going on as the sun moved across the sky. Some of the video footage I put up on YouTube, such as the video you see on your screen now, which is from May 23, 2016. And there's a bit more that I have. I paused, that is, the project, because some of the anti-flat earth opponents came out with pretty good objection to the video coverage, saying it's not really showing sun shrinkage or sun changing size going on. It's showing a difference in glare based on the light output of the sun, which changes through the course of the sun in the sky through the day, but does not show a change in the size of the sphere as it appears from Earth in the sky. Okay, so that's a very important point, which I'm not saying I didn't think of it, but the flat earth opponents who pointed it out did a pretty good job and sort of made me understand that this is a serious problem. So I took the videos down to give myself some time to work on this further, to try to see what the videos meant, because I was convinced that they were showing sufficiently sun shrinkage going on during sunset, which showed the sun is moving across the sky. A low, small sun, according to the flat earth model, is moving across the sky rather than a very large, very distant sun, which appears to be moving across the sky, but is actually not. It's the Earth is turning, so it appears to move across the sky, but it's actually roughly stationary from its positioning from Earth. So it is a very good objection. Let me just state it again in different words. According to the heliocentric model, the ball of the sun will not change its size and appearance as it moves across the sky from the first of the morning through sunset. It will stay the same apparent size, but the glare of the sun will change dramatically from the lowest points of the sky to, for example, the highest, and that will change greatly. Okay, glare being picked up on a camera, and opponents of flat earth were saying I was picking up just the glare, not the sunball size changing, and I thought it was a pretty good objection. I was disappointed in the objection because I was very convinced that we were not picking up on a change in glare, but we were picking up on a change in the sunball size. But I nevertheless could not avoid the possibility of what the flat earth opponents were saying. So took the videos down to process, to think about this, not make a quick reaction. Didn't know it'd be for 3 years, but I'm extremely busy in seminary and in ministry right now, so it's taken a little bit. But again, time frame is not really the critical issue here. It's accurate results, which is what I'm trying for. So we'll see how this goes, because I think I found a way to figure out how much glare is being recorded and not recorded here, which I'll explain in a minute. Now, there's a tremendous amount that can be said about this topic, so I'm going to, in this video, cover one specific project, and that is to specifically instruct on how to do and demonstrate examples of filtered solar footage showing the sun changing size at sunrise, getting bigger, getting smaller at sunset, because the sun is not stationary in the sky but is moving closer, passing overhead, and getting smaller as it moves away, all of which will be demonstrated on an iPhone with a $5 solar film. So it's dirt cheap, and anybody can reproduce this to ascertain the results with their own eyes, and so forth. Analyze various results and show at the end a specific result which involves no glare and shows the sun to shrink in size as it sets. In other words, to move away from the camera, from the observer, as the sun courses downward in the sky, which really means it's going further away according to the perspective line. That is what will be covered in this video, and it will be definitively shown through a series of measurements, a few of which fail, but the last of which does not, and shows that the sun does shrink in size as it moves across the sky in a sunset. So in simpler terms, we're going to discuss what is required to do a proper filtered solar time lapse. So it is ascertained that we're not measuring glare, and we are measuring the size of the sun. We will find a specific way to determine how much glare is or isn't present in filtered solar footage. And then we will go through examples of footage of solar time-lapse filtered video, showing how there can be successful and failed tests, ultimately to wind up at the last example, which perfectly shows filtered sun footage and a shrinking sun size at sunset due to the sun moving away. I will now proceed to discuss, firstly, how we can determine how much glare is being recorded in solar film filtered time-lapse video footage, or just with a camera snapshot with filtered footage. How do we know how much glare is being recorded and how much of the actual shape of the sun is being recorded? Using the solar eclipse of 2017, I will be able to determine how much glare is actually being accounted for. And after that is determined, we will then go through various solar tests that I've done using filtered footage to specifically find the way to do a successful test, which will determine sun shrinkage upon sunset, which confirms the Zetetic model of flat Earth reality and disproves the heliocentric model. To repeat what I said above, this video is several years in the making due to processing the results and coming to the answer of the solar eclipse is showing how much glare is present in solar filter footage, as will be discussed shortly. I would just say briefly in passing, I was prepared to alter, if needed. I didn't get to this point, but I was thinking, if the sun size is measured to not change through the sky as the sun moves across the sky in its appearance throughout the day, I was not going to abandon the flat Earth model. That would have definitely, until an explanation is found, it would have been a negative for flat Earth model. I'm talking about my own flat Earth model, by the way. I'm not talking about other a lot of times when I say I'm a flat earther as a zeteticist, people immediately lump me in with all the others, saying that the sun is just above the clouds and all this kind of stuff. I've got my own flat Earth model that I've developed, which is strictly empirical, which really has very little to do with the popularly discussed flat Earth information that is out there, which involves all sorts of things, such as the moon is in front of the clouds and so forth. And my model is involved with almost none of that. It is strictly based on my own empirical measurements of reality and trying to ascertain the shape of the world that we live upon. And the results that I've come to, I've put into a model which I call the Zetetic Eye Gyroscope. And the model successfully describes many things that other flat earthers cannot describe, such as the star trails in the north and the south and the tides and so forth. And I'm talking about these can be described empirically, not through some idea alone that does not have directly observable verification that is possible by anybody who wants to go look. So back to my point about the sun size, I've seen enough in my model, the videos on my channel, which prove in my mind, there was no question that a zetetic model was correct. So to say all of a sudden have one problem emerge, that the sun size isn't changing, definitely would be a concern. But there's still all the other points, like the sunlight patterns in the water. Massive evidence for the Zetetic Eye Gyroscope model. Huge, huge empirical evidence that anybody can verify. Radically, purely scientific data, which is a complete strike against heliocentrism and an absolute plus column for the Zetetic Eye Gyroscope model of flat Earth, which involves a salad bowl, gradually curved zetetic plane, as stated in Zeteticism Volume 1 and other videos I put out. So anyways, back to the point. So as you can see on your screen here, there's the two circles, the bottom and the top. This is just simply a picture from a video 7 minutes and 43 seconds in that I did. Flat filtered sun shrinkage public test number 1, 5/23/16. Introduction to a much larger study going on. Yeah, that I plan on doing many of these videos and figuring out the way the sun changes size and so forth, and figuring out all kinds of data to make all kinds of findings with Zetetic Earth. But then I ran into this snag and sort of put it on the shelf, being very busy and just sort of processing it in my mind. But I have found a way. So the question is, how do we determine how much of this glare is deviating us or hiding the size of the sun's diameter? That's the question. Let me put that in different words. So we see the images you see above your screen. One, when the top one is when the sun's higher in the sky, and the bottom one, the sun's lower. You can see that one is smaller than the other. But am I measuring less glare, or am I measuring the sun itself shrinking in size because it's moving further away and being, near the Earth, as the flat Earth model involves? So the sun gives off the same amount of light, but when we're seeing it near the surface of the Earth at sunrise or sunset, more light is traveling through the atmosphere, a thicker patch of atmosphere, and that could lead to it dimming. That's the idea. That could be going on. So it's brighter when it's higher in the sky and dimmer when it's lower down. So that would mean that there's more glare in your camera when it's higher in the sky and less near the horizon. And you're getting less glare. So it looks like it's changing size, but it's really not. So the question is, how do we determine how much glare is going on? Long story short, I've found a way to analyze sun shrinkage footage using a solar film and a cell phone and time-lapse video to find out how much glare there is. And that was with the big eclipse that happened a few years ago. And I only thought of this when I was looking through some old pictures of the eclipse through solar film a couple months ago. I realized, hey, that's a pretty crisp image. It's not a big blob. You can decipher the structure of the sun changing during the eclipse. So therefore, you can tell how much glare is going on. And if there's not much, then that tells us something, that our time-lapse photography is recording a change in the sun size, because the glare isn't as much as we thought. It's not recording a change in just a lot of glare and hiding the sun size behind it. Putting that in different words, the image you see in your screen is through solar film with a cell phone. And it does have glare. See all that gold or copper, you could say, around the sun? That's all evidence of glare. But we can still very specifically see the chunk taken out to the right there of the sun. It's a relatively crisp picture. Not perfect, it's going to have fuzzy edges and so forth, but not bad. Now the point is that picture has some glare, and we can still decipher the shape of the sun. Now if we're measuring predominantly glare, we would not be able to decipher the shape of the sun. We would measure a glared image, a big blob, not this crisp image. So glare is not nearly the issue that the objectors back in 2016 made it out to be. Now their objection is good, and we need a way to determine how much glare is there on this primitive cell phone solar film solar photography. And this eclipse settles that issue. And the answer is, if there's glare, we still measure the sun size itself. Not merely a quantity of glare, but the sun shape and diameter itself is predominantly what's going on here. Now we still have to be careful about glare issues, but that's not the dominant factor, and we can trust cell phone footage with solar film filtering the footage. And if we therefore measure a change in the size of the sun, we are measuring the sun shrinking and or expanding, or therefore, in other words, getting closer at sunrise and going further away after it passes overhead and into sunset, which would be a truly massive home run piece of evidence for the Zetetic model, and a serious problem, yet another one in the long list, for heliocentrism. Now this would have to be repeated using the primitive apparatus, solar film with cell phone, by many people, myself included. People will have to wait till the next eclipse to do this on their own, to verify for themselves that, you know, if you have a cell phone, you buy a $5 piece of solar film, put it over it, get a free time-lapse app, or just taking pictures. You can verify how much glare you have. But we can see here, we don't have an incredible amount of glare. In other words, you can see the outline of the sun. It's just not a big smudgy blob. No, we can clearly see that we're measuring the sun size. So therefore, if this image were to get larger or smaller, we're measuring the change in the size of the sun more than the glare of the sun. Now this picture here is very telling. I was taking solar photography of the solar eclipse during a time when clouds were passing by. Now this should lead to great increased glare and really distort things tremendously. But you can still see the C shape of the solar eclipse there. This is at the peak of the eclipse, around the peak. Okay. Now, if we were measuring glare, or predominantly glare, this image here you would not be able to decipher the structure of the shape of the light source behind it. It would come at you looking like a headlight of a car. All radial patulous rays of light coming from the central source. Okay, but that's not what you see. Just like with the other pictures that don't have the sun coming through a cloud, you can clearly make out what's going on. It shows that glare is not the dominant issue that's being measured in this primitive form of solar photography and video. And if that's true, then every person on Earth, if they just have a piece of solar film to put over their cell phone, we'll be able to verify solar shrinkage and expansion as the sun moves across the sky, which would be another massive data point for the flat Earth model. Pure science, because everybody on Earth can verify it, unlike the science of NASA, which cannot be verified by only but a few, as discussed on previous videos I've made. Now this picture here was a few moments before the picture you just saw, with the cloud coming over. It's going to be between the sun and the viewer. And notice the pictures are not very different. You've got definitely more glare in the one with the cloud, of course, as expected. But clearly you can make out the shape. You know exactly what's going on in both. There's glare in both, but you know how much. It's limited. Okay. Now this is more dramatic when we go to some of the pictures when the sun is in very low state of eclipse, when very little of the moon is going in front of the sun. So let's compare this picture taken during the eclipse with the original picture from the May 2016 video YouTube cover I just showed you a minute ago. So right here, here's the two compared. Let's compare the bottom image. Doesn't really matter, you can do the top or bottom, but let's do the bottom image with the eclipse picture. Now you can go watch this May 23, 2016 video on Zeteticism.com. And the sky's quite clear, but there's massive glare in the video. Far less than the solar eclipse picture you see here. Here's the time-lapse of it. See the glare all around. Now that is alleviated by turning down the settings on the camera to avoid all that glare, which we'll do in later time-lapse examples. So let me go to a different video time-lapse that I took on August 22, 2016, in fact. I was doing time-lapse photography almost every day in anticipation of putting up many videos before I hit the aforementioned objection that I pondered, as I discussed at the beginning of the video, from anti-flat earth proponents, which put this whole project on pause until I realized the solar eclipse settles this issue. So I'm going back into that footage. So let's look at this footage here from August 22, 2016. And here's the time lapse that I obtained, and you'll see at the bottom, at the end of it, are those tree branches that are captured in the footage. Okay, so unfortunately I bumped it around a few times, but I'll show some more footage here in a second, which does not involve that. But let's analyze the changes here. So let's compare 4 images in the time lapse here from Muskegon, Michigan, on the beach. And you can see obviously there's the shrinkage. Now the question would be, how much glare do we see? Now we can compare the solar eclipse footage as we do right here. And the solar eclipse footage tells us how much glare there is. And we can clearly make out the nature of the sun during the solar eclipse, which has less light output. But it's still the blinding sun. It still should involve some glare, so that it does not disrupt us from clearly being able to delineate, see the boundary of the sun. It tells us that the images we're seeing here of the filtered sun are also roughly of the edge of the sun. Not a glare boundary, but a boundary of the sphere of the sun. That's what we're measuring in the time-lapse filtered sun footage here. So therefore, you're seeing the sun shrink in size, not the glare decrease and diminish through time as it goes through greater atmosphere. If it were the case that the glare were decreasing, then it should also be the case not only that the filtered solar eclipse should become crisper as light output decreases, which it does not. It stays relatively the same unless clouds and atmosphere make it somewhat more blurred and glared. Not much though, as we saw a few minutes ago. But to return to the obvious and central point, if sun glare were being what's measured here, the solar eclipse, such as the image you're seeing here, would not be clearly visible as a solar eclipse with only a piece taken out. That should be hidden behind the great glare of the sun, which it is not. Therefore, we only can conclude that the solar filtered sun is a time-lapse film of the size of the sun shrinking. Now I'd like to show you a particularly interesting study, also one I recorded back in 2016 on May 31. This one is on a kind of a hazy day. So we have some glare, but we have the color of the sun through the filter does not change from being more yellow to more red. It stays exactly the same color the whole way, which should indicate we're getting a comparable glare. And you do see the edge of the sun at the end to be exactly the same. Here you see the setup I'm showing you back from May 31, 2016. Now, and the sun clearly changes size, gets smaller. Now, this footage here from 2016 does not involve me bumping the camera around as I was on the windy day on the beach in August 2016 from Muskegon. This is from my former home just south of Ann Arbor. The jars and so forth that you saw there in the setup, those were just to hold the camera in place, the phone in place. I explain a little more of the setup details in the other video back from 2016 that I posted, which I start off this video comparing to, which you can go back and watch on Zeteticism.com. So here we have the two images. The start is at the top and the conclusion of the time lapse is at the bottom. You can see right there that one is larger than the other. Let's compare the boundaries of the two, as that is an extremely important issue in this time lapse. So just move chunks here of the top one to line them up in the bottom, and you can see that the boundary has sort of the same amount of fuzz, so to speak. It has the same level of imprecision, both the top and the bottom. That means the same level of glare should be accounted for in each, which is incredibly low from the way I have the settings on the camera, given it being filming through the solar film. Okay, and again, as stated, our evidence that there's very low glare is also found in the sun not changing color here on this hazy day. So the only way you can have the sun getting smaller in this time lapse is through it actually getting smaller. Okay, so a couple of things we should say. One, to repeat what I've said 3 years ago, why are we doing time-lapse footage on an iPhone camera with solar film? When I came out with these tests People criticize the tests as being poor because of the bad equipment, which, strictly speaking, yeah, they are a lesser quality. The goal here, however, is mass reproduction of the experiment. We want everybody to be able to do this so they can see with their own eyes. So all they have to do, everybody's got a cell phone already. All you have to do is order a $5 piece of solar film and get the free time-lapse app on your phone and go take time-lapse photography and then analyze the results. So really it's $5 to get the solar film. So therefore it's true science. Everybody can reproduce this. It's not the sort of NASA style science where virtually nobody can reproduce it. In other words, not science. But to get back to the original point of this video, the ultimate point that needs to be made here is the eclipse footage of $5 solar film filming a solar eclipse shows that glare is not a factor in being able to decipher the boundary of the sun from a simple cell phone camera through solar film. For that reason, we must conclude that we are filming the boundary of the sun through time-lapse footage, through solar filters, through solar film on time-lapse video on a cell phone. Therefore, we are not measuring a change in glare due to a change in light output through the changing level of atmosphere, but nevertheless remains the same size as the heliocentric model would involve. On the contrary, the better model is to say that the sun is actually changing size, and its boundary is being measured as doing such, and glare is not the factor, as was found to be the case with the solar eclipse footage. We will return to this May 31, 2016 time-lapse analysis later in this video. Here is another test I'd like to go over with you. This has many interesting points to it. This is from June 24, 2016. So there's, like I said, I've got a lot of footage from this time. I haven't done any tests lately. I need to get some new solar film. I've kind of lost track of everything. Just going on my old footage. But this footage sort of shows a couple things. Again, how sun shrinkage with glare not being an issue is measured. One thing that we have to notice that's truly amazing about this filtered footage is the level of brightness around the sun image throughout this filming on this very clear day is virtually identical throughout the film. In other words, the glare level is exactly the same throughout the film. So the solar eclipse footage then tells us we are measuring truly the size of the sun, not the glare of the sun in this footage. So this footage is very important here. And we can do a comp. Let's take two images at the beginning here, and then at the end, get them lined up next to each other. Again, you should all do this on your own. I'm just showing you what to do, my results, and so forth. It's not science until you do it on your own. It's not Zeteticism until it's a group experience. So anyway, if you look at the two images here, the bottom one is smaller. The sun has, in appearance, has gotten smaller in size. Therefore, the sun has gone further away. Okay, so I've drawn circles around each image trying to show the difference in size. So more importantly, I took chunks from the top to the bottom, put them in the chunks from the top into the bottom image to compare what we're looking at. I'll have some overall comments about this in a moment, but let me just try to give my opinion on what we're seeing here. I think that outside, the chunks move down into the lower image, the second image, the later image. I think that outside the circle, obviously it's brighter. What does that mean? Does that mean that the circle is not large enough up high that I drew on the top picture, or does it mean that there is glare there? Because if you look at the image to the left, this square moved down to on the left side, there's very, very minimal difference outside the circle, yet inside the circle the brightness is much greater coming from the top. All of the images have more brightness inside the circle coming from the top to the bottom, indicating a larger image. Okay, so is it the case that we should have drawn a larger circle? Well, let's try to do that right now in order to get boundaries that match better. But before we do that, these results here would match what we'd expect if the sun was moving away, not decreasing in glare. But the question mark would be outside the circle that is slightly brighter. That's what needs to be addressed. That's what the opponent can come along and say that it is brighter outside the circle. So is there glare that's being measured? So let's draw a larger circle on top to try to match these boundaries better to see what we do. What we want to find is the same, virtually unchanged from outside the circle, top to bottom, but brighter inside the circle on the top and not the bottom. That would indicate, it would seem definitively that the sun is decreasing in its size, not glare. So let's do that now. So to do this second analysis, I've drawn two circles that are exactly the same size over each image. And so we only care about the diameter changing, because that will not change by refraction. Okay, so let's take two chunks and look at them. Take them from the top and bring them down to the bottom. Now what we should, if we have no glare and a shrinking in appearance sun sphere, we should expect inside the circle to be greatly increased light from the sections being brought from the top picture down to the bottom, and outside the circle we should expect no change. So what do we get? We get some change on both. However, it would seem the change inside the circle is far greater. So if you bring these chunks down here, as you see on your screen now, outside the circle, the chunks brought from the top to the bottom, there is an increase of light. Inside would seem to be a much more dramatic increasing. So this would point towards the idea of sun shrinkage in appearance, not measuring glare. Now, to be fair, there could be some glare going on here, but again, since there's more light measured inside, increasing versus the decrease in outside would point to sun shrinkage. Now let's step back a second and think about what has been analyzed, and look at these two images here. We have to admit the images are similar. We have to be in a pursuit of the truth. We cannot let bias enter in here. If you're a flat earther, you have to fight the urge to want there to be a difference here that's measurable, and the sun is seen as shrinking in appearance. And if you're not a flat earther, you have to fight the urge to hope that the images are similar. What I mean is we have to just look at the results. To be honest, we're measuring from incredibly primitive, low-tech equipment. The differences we're measuring are with very fuzzy boundaries, and the difference is not great. But there is a difference, it appears. Some tests I did, I can only be honest, the difference was small enough to where you almost could toss out the results. Not quite, but almost. Most of them were like this one, June 24. Again, I put more up. When I get time, I'll put more up. Or do new ones as well. Let's just see what the future holds. In my opinion, it would seem, in stepping back and looking at all of this analysis, going all the way back to the first video I put up measuring the sun time-lapse on solar film with an iPhone in May of 2016. Now, I had some other videos up as well. I must have deleted them or something, just kept the one from back then. So anyway, that's why some of this additional footage here. It would seem the best conclusion is we are seeing the sun change consistently in size, in its appearance, that is. That would be my opinion. Obviously, better results need to be taken into consideration. And the most important thing that can be said in this video is the only results that matter are the ones you do on your own. Anybody can fake anything they want on YouTube. I've seen people put all kinds of results. The sun's shrinking, the sun's not shrinking in appearance on YouTube, and people take it as if it matters that these results are being put up, and it really doesn't. The only results that matter are the ones you do on your own. Go buy a $5 piece of solar film, get a time-lapse app, do this, and see for yourself if you measured the same. If you do, get the results as you're seeing here. It probably would be the case. The best conclusion is we're seeing the sun shrink in size and its appearance. What other conclusion can we come to? The glare is not what's measured here. So it would seem from my results, and I've shown you the address of where you can get your own filtered sun filter material, solar film, and I got that from an anti-flat earther. But regardless, get whatever film you want. I think this solar film is the best. It's better than welding glass. Welding glass has a tremendous glare. I did welding glass experiments and got far more pronounced sun shrinkage results, which told me I was measuring glare. And the sky's all bright green. See how the sky's all bright green at the start and then dims way, way down? That's because there's all kinds of glare that we're measuring. This is what the anti-flat earthers were saying in criticism of my results in 2016. They were saying I was measuring glare. Now, this welding glass video footage here is important because it involves the sun going behind the trees there in the backyard of my former home. Now, the solar film footage we've seen so far, and we will see more examples of after this, does not involve me filming through those trees. Okay, the welding glass I did before leaves were on the trees. Then afterwards, I started doing solar film footage. The leaves had come on the trees in April and May in Michigan. So I was taking footage higher up, which would involve less pronounced results. Now, I don't know what we're seeing here with this welding glass information. It's definitely possible that glare is amplifying the change in the shape of the sun. The sun boundary is very fuzzy in this welding glass footage. But from what we're seeing with the solar film in this video and what's been seen already and what will be discussed further in the May 31, 2016 solar film video footage that I'm going to come back to in a minute, there is change in the size of the sun being accurately measured here in the welding glass. The question is, again, we don't know how much of a factor glare is. We'd have to measure the solar eclipse through this same piece of welding glass, which gives it a green tint, to find out how much we can decipher the size and shape of the sun. Therefore, we could know how much of the boundary of the sun we're really seeing and how much is really hidden behind a glare image. That's why I'm not using the welding glass footage, because I don't have the eclipse to compare it to, and it does look like it has a lot of glare. The solar film clearly blocks out far more light, which is what we want. So returning to the June 24, 2016 footage we were analyzing before we started looking at the welding glass footage, could this be definitive empirical verification that the sun, through filtered footage, is shrinking? Perhaps. More analysis needs to be done. Again, it doesn't matter what anybody puts on YouTube. It only matters what you measure with your own eyes, because then it's science. Now, let me show you another video. This is one of the ones I mentioned a few minutes ago, where you couldn't really, you kind of could see it change, but it was so minimal you almost want to throw the results out. Okay, so this one's from May 25. So this is a sunrise. Here's my setup. As you can see, it's very hazy. You don't see pure blue sky as the one we just analyzed a moment ago and appeared to have seen measured shrinkage of the sun. This one is one where we don't, you do see some, but it's so minimal, like I said, that you almost want to toss the results. Perhaps the haziness is the reason why. And in the footage we're about to see, you can see glare. Look at these two images. The top is the one we just analyzed. Okay, and you see that black background. The glare is absolutely minimal. At an absolute minimum. Now, the bottom image is the sunrise we're about to look at right now. Look at the difference there. There's tremendous glare. The whole copper colored background all over there. So that would appear to be the problem here. And this would be a test that should be tossed out because of that glare. We will still see perhaps a little bit of sun expansion on the sunrise in its appearance, however, but it is a fuzzy conclusion. So here is the footage. You can see the sun's pulsing there. That's just diffraction from the sun passing behind some telephone wires, so that can be ignored. And what you see the glare-filled sun all the way up. So now we'll compare two images here, which we would expect on the Zetetic model that the images get larger since we're looking at a sunrise. So still number 1 here is shown in the top is at the start, and still number 2 at the bottom, both filled with glare. So let's put the two images next to each other, very close. And again, the bottom one is the later one. Let's line them up and draw some parallel lines to see if we can notice any change in the size. And you see for yourself, not much. And look at all that copper background, which dramatically increased in brightness from the first image on the top to the second on the bottom, showing that there's tremendous glare going on. So you can see here how to do this test. It would appear that the camera settings would need to be more like the May 31 test that we just looked at and are about to look at again. That would appear to be the culprit for this glare, which is not allowing us to view the sun's size, and glare is distorting things. If it's the case that the sun is expanding in its appearance, as this video will conclude. You could perhaps discuss the hazy skies being a cause, but recall we had a test we looked at a few moments ago that was of a hazy sky, and we had very successful non-glare filled results, which did reveal shrinkage. That's the sun going down. So it would appear the camera is letting in too much light here on this test. So it would appear that the best analysis clearly is to throw the results in this one away. You can't really tell. You may be able to say there's the first image is distorted in a way that can lead you to hypothesize there's a smaller image in the top, but I wouldn't use these results. I think they should be thrown away. Now let's go to by far the best test, which could possibly be the sort of test that will settle the issue. And this is the May 31, 2016 test from Michigan, just south of Ann Arbor. This one has literally no glare. Here you can see my setup, and here you can see the footage. We'll analyze this very carefully, and you can take this footage as well and analyze it just like I am, and do your own, more importantly. Here are my camera settings. This one involves no change in the color of the sun, indicating zero glare, and it involves no change in the background behind the sun, indicating zero glare. And what we see is a change in the size of the image. This would clearly point to sun shrinkage in appearance. Now in this footage, I don't have the zoom on. It's hard to get the camera situated with the zoom. That's why I didn't often do it. And also there's fluctuation, obviously, that you can see. Have to make sure you don't compare images that have fluctuation involved. So this would have to be an experiment done over and over. But this is sort of the setup we're going for. Sun color doesn't change. Crystal clear blue sky. Zero glare involved in the background. This is the setup which should repeatedly show the image change in size. Now I'm doing short time lapses here because my old backyard, my old house, had a bunch of trees and I couldn't get all the way down to the horizon. And so you could theoretically do 2, 3, 4 hour time lapses to get much better results. And I will try to do such a video in the future. But let's compare these images here you see on your screen, and it's very clear. The results showing that the sun changes in size. So in other words, when we got down to the purest, best analysis, really following what the anti-flat earthers in 2016 said was the problem, is glare, measuring glare. Learning to get this kind of footage here, just on an iPhone with solar film, where there's zero glare, does reveal a sun image shrinking in size, as we're going to find out right here. This is a first introductory attempt to show how to measure sun shrinkage, which should be done over and over. More tests should be put up, but the only tests that matter, again, are those we do with our own eyes, not which we follow on YouTube or some other website. So anyway, the first image is the sun higher in the sky, closer. The second is it lower in the sky, further away. Take a chunk from the right, bring it down to the left. Try to match up the backgrounds and the boundary, and we see a brighter sun image. The chunk brought down is brighter. Okay, now let's bring the whole half almost of the left side down and match it up exactly in the same location. Just bring it down directly and look what we see, how much bigger it is than the bottom image. Depending on further analysis in the future, this could be potentially very powerful information, indicating primitive measurement with solar film and an iPhone and time-lapse video showing sun shrinkage, which is impossible with heliocentrism and required with the Zetetic model. This would appear to be such a measurement. Now, one last incredibly important comparison. Take a chunk out of the whole top half. Bring it down to the bottom. You can very clearly see the larger magnitude of that top earlier image of the sun higher in the sky as compared to the lower in the sky image. Anybody can verify this. And furthermore, look at the way those backgrounds merge. There is zero glare being measured here. Glare is zero cause of this image change that has been measured. Only the sun size is being measured here, and the sun size is measured as shrinking. Again, I've shown you all the measurements. I've shown you the solar film used. I've shown you the camera settings on my iPhone. I've shown you virtually everything to do this test right here, to gain these results, where you should be able to repeat this every day, that is a crystal clear day, and find the sun shrinking in size. Now, somebody could object and say, look at the fuzzy boundaries of these pictures. If we're comparing to the solar eclipse pictures to gather our information about the nature of the boundary, well, this is apples and oranges. These are very fuzzy boundaries. I believe that's because with the solar eclipse footage, I was on fully zoomed. In this video here from May 31, 2016, I had no zoom going at all. Again, it's hard to center the video exactly right on the cell phone with the zoom. The image goes off screen, so forth. That happened in a lot of time lapses I would do. Mistakes would happen, so I would just leave it off zoom. I never knew that this would amount to much, this footage, so I just let that go. And I did not do any time-lapse footage during the August 2017 eclipse. I didn't know the significance of it. I kind of wasn't as involved with this as much. I was just sort of pondering the results, trying to get around, figure out, deal with, or accept the objection that the anti-flat earthers proposed to that I was measuring glare, so therefore I wasn't as active in my measurements and collecting data, so I didn't do any time lapse of the eclipse itself. So, but anyway, I think these boundaries are as fuzzy as they are because I'm zooming in a very small image on the computer rather than having it zoomed on the camera itself, which the eclipse pictures were. So in the future, what somebody would want to do is take these camera settings here and zoom in and get video footage on your cell phone on full zoom, which I'll try to do in the future.